Hi, good morning. This is Visankar Naidu, lecturer in physics. Today I am going to discuss a topic simple harmonic motion. Here, see this. Simple harmonic motion. It is simply named as SHM. Here, before going to know about simple harmonic motion, we have to know about periodic motion. What is periodic motion? Periodic motion. Here, periodic motion is nothing but the motion of a body which repeats itself in a regular interval of time is called as periodic motion. The motion of a body which repeats, see this, the motion of a body which repeats itself in a regular interval of time is called periodic motion. Periodic motion. Here, see this, the motion of a body repeating itself in a regular interval of time. This type of motion is called as periodic motion. The example of periodic motion is that already we know from our childhood, Earth revolves around the Sun. Is the example of periodic motion. See this. For suppose this is the Sun and this is our planet Earth. Now see this. See this. Here our Earth is revolving around the Sun, and also the motion of Earth is repeating every 24 hours. For every 24 hours itself. So the motion of our Earth is the example of periodic motion. Here, next, we have so many examples like this. That is when a string, or suppose this is a string, is fixed in between the two ends and then plucked it. So when we plug the string, what happened? It vibrates up and down. This is also one of the example of periodic motion. Our heart beat also one of the example of periodic motion. Now we are going to discuss about simple harmonic motion. Simple harmonic motion. Yes. Here, see this. Simple harmonic motion. It is very easy to understand. Simple harmonic motion. Simple harmonic motion is a special type of oscillatory motion. Oscillatory motion. That is, a body is oscillating to and fro about its mean position, then the body is said to be in simple harmonic motion. To understand this one, here, see this, I am drawing some examples. Here, see this. Now take a spring which is attached to a mass M. It is at a mean position, that is, it is at rest position, no force acting on this one. This is the case one. Now, when this mass is pulled to a distance x from its mean position, this was second case. Now what happened here? We are pulling the mass from mean position to a new position of a distance x. Then now see this third case. Here see this, what happened? Here observe these two cases. First case is the oscillating body is at rest position. Now when we are pulling this mass to a distance x from the mean position and then released, what happened? It overshoots the mean position and reaches a above of the mean position, which is the above the position to a distance x, and it can't stop here, and it continues to oscillate up and down about the mean position. This type of motion is called as simple harmonic motion. Simply we say that whenever the body is said to be in simple harmonic motion, the body must move to and fro or up and down about the mean position in such a way that the acceleration of the body is directly proportional to its displacement, but it is in opposite direction. Then the body is called as simple harmonic body. Here, see this is the condition to understand. Here, this is the displacement of the mass from the mean position. It is in this direction. This is in this direction. Now, once we release this one, what happened? The body moves towards the mean position. That is, the body accelerates towards the mean position. See this. Acceleration is directed towards the mean position, but displacement is away from the mean position. Both are in opposite direction. In the above case is also true. Here see this. The displacement is in upward direction and the acceleration is in downward direction. Means that the acceleration towards the mean position. In this case also both A and X are opposite to each other. That's why minus we written here, minus represents A and X are opposite to each other, and A is directly proportional to X. That is when the displacement of the particle X increases from mean position, the acceleration of the particle will also increases. This is the definition of a simple harmonic oscillator. Now to understand simple harmonic motion, we are going to discuss about some physical quantities such as displacement, velocity, accelerations, time period, frequency, and so on. So first and basic physical quantity is that displacement. Here see this, displacement. What is a displacement? As we know that from our childhood, the shortest distance in between the 2 points is called as displacement. But in this case of simple harmonic oscillator, we are taking the same thing but something different. Like this, to understand this one, I am taking an example of simple pendulum. A simple pendulum is nothing but a mass M is tied to a thread and it is fixed to the roof. Now this mass M is pulled to a distance x. Here this is the mean position of the ball and this is the displacement. See this. Here the position of the mass from the mean position is called as displacement. See this, the position of a mass from the mean position is called as a displacement. The displacement has an equation, that is x is equals to a cos omega t, we take in cosine form, or y is equals to a sin omega t. Here the displacement of the bob or mass is also true on other side of the mean position. So here it represents the distance of the position from the mean is called as displacement. Now we can also derive these formulas by using of the projection of particle on uniform circular motion. Projection of particle on uniform circular motion. For suppose take a circle of center O, draw a diameter along x-axis called as xO, x dash. This is y, O, y dash. There are two diameters. Now it has a radius a. Let us consider a particle P is at this position making an angle theta at a time t, when the particle is moving with a velocity omega along the circumference of the circle, the position of the particle is changing s. Now to know the position of the particle, we draw the normals on x-axis as well as y-axis. These are the two normals named as m and n. The m is the distance x from the mean position and n is the distance of the from mean position. Here these are the angles. Now clearly it is understand, when a particle moves along the circumference of the circle, the foot of the perpendicular will also move along the xO, x dash as well as y, that is the move the foot of the perpendicular moves along the YO, y dash. That is the foot of the perpendiculars m and n are moving along the diameters xO, x dash and YO, y dash respectively, when the particle moving along the circumference of the circle. Here from this we are understanding that the foot of the perpendicular m moving along the diameter, see this, it is moving towards the x dash and again moving towards the x. That is the foot of the perpendicular moving back and forth along the xO, x diameter. In the same way, the foot of the perpendicular n also moving along the diameter YO, y dash. So that this is the best example of uniform circular motion of particle moving with a velocity omega. From this diagram it is very clear that, for suppose we know that sin theta, that is sin theta means here omega t, here theta is equals to omega t, that is angular position. Sin omega t is equals to, what is this? We know that the formula sin theta is equals to opposite side by hypotenuse, opposite side by hypotenuse. So what is an opposite side? See this is the opposite side y and hypotenuse is what? A. From this we get y is equals to a sin omega t. So this is the displacement equation. When we take this one, we get x is equals to a cos omega t. That is, we can represent the displacement of the particle from the mean position by using of these any two equations, y is equals to a sin omega t or x is equals to a cos omega t. Now we are very clear about the displacement. Yes. Once again I am giving definition. What is the displacement of particle? The displacement of particle we can measure from its mean position. That is, the distance of the particle from the mean position is called displacement, which is given by y is equals to a sin omega t. That is, I am taking in form of sin. Y is equals to sin omega t. Now in this equation we have a term called as A. What is A? A is amplitude. A is amplitude. What is amplitude? Amplitude is nothing but the maximum displacement. The maximum displacement of the oscillating particle. The maximum displacement of the oscillating particle from the mean position. From the mean position on either side. Here see, here a simple pendulum diagram. See this. This is the mean position of the simple pendulum. Here these are the extreme positions of the simple pendulum. That means after this point the particle can't go. So that here this is the extreme position on left hand side. It is given as, so I am writing this on small a and small b to understand this one. We take in here capital A. Here this is what x is equals to a. Here we know that what is x? X is the displacement of the particle from the mean position. Here whenever the displacement is maximum, it is named as amplitude. It is named as amplitude. So see this. Here we take an x or otherwise y is equals to a. Simply, what is the amplitude? Amplitude is the maximum displacement of the oscillating particle from the mean position is called as amplitude. Now, next, going to discuss about velocity. Here what is velocity? As we know that the rate of change of displacement gives the velocity. Here v is equals to d by dt of y. That is, the displacement of the particle is changing with respect to time. It gives rise to velocity. Here when we differentiate the displacement y with respect to time, then we get velocity. See this. Y is equals to a is a constant, it is an amplitude, d by dt of sin omega t, d by dt of sin omega t. Now v is equals to a into, what is d by dt of sin omega t? As we know that the formula d by dx of sin x is equals to what? D by dx of sin x cos x, or d by dx of sin ax is what? A cos ax. So this d by dt of sin omega t like this formula, that is sin ax. Now differentiate, we get what? A omega cos omega t. A omega cos omega t. This is a very important equation, velocity, equation number 2. The velocity of particle can also be obtained in terms of displacement. See this, as we know that sin square omega t, that is take theta to understand, sin square theta plus cos square theta is equals to 1, as we know that soon. Now what is cos theta? Cos theta is equals to root over 1 minus sin square theta. Now from this we are replacing this one. We are taking theta as omega t, cos omega t, square root of 1 minus sin square theta. Sin square theta, here see this from this equation. Sin square omega t is equals to y square by a square. Y square by a square. Now putting this value in this equation 2, we get v is equals to a omega. What is cos omega t? Cos omega t is root over 1 minus y square by a square, which gives rise to us omega root over a square minus y square. So this is the velocity expression. I am writing this one clearly here. See this, velocity v is equals to omega root over a square minus y square. So this is one of the expression in terms of displacement of the particle. It is very important equation in numericals, that is such as in competitive examination they will ask you to find out velocity of a particle, then we use this equation. Now from this equation it is very clear that when the particle is at mean position, while it is oscillating, what about its velocity? Here see this, when a particle is at mean position, nothing but the displacement of the particle is 0. Now putting this value, we get v is equals to omega into a. That is, we are getting maximum. We are getting maximum velocity when a particle is at mean position. Now when a particle is at extreme position, that is y is equals to a. Here when y is equals to a, v becomes minimum. V is minimum, that is the velocity is maximum at mean position and the velocity is minimum at extreme position. So this is the information about velocity. Now acceleration. What is acceleration? Simple. The rate of change of velocity is known as acceleration. A is equals to d by dt of v. What is v? Just we derived, that is a omega cos omega t. Here see this, a omega are constants and cos omega t we have to differentiate. Then we differentiate, then we get minus omega sin omega t. Then a is equals to minus a omega square sin omega t. Here now a is equals to minus omega square into y. Here say a sin omega t as in the form of displacement. Here we have two expressions. One is a is equals to minus omega square into y, and a is equals to minus a omega square into sin omega. These are the two expressions of acceleration. That is equation number 3, equation number 4. Now from this equation number it is very clear that acceleration is maximum when the acceleration is taking only magnitude a max, that is right, this one, a is equals to omega square y. When y is equals to 0, when y is equals to 0, what happened? A is equals to 0. A is equals to 0. That is at the mean position. That is at mean position, the acceleration of the particle is 0. The acceleration of the particle is 0. And when y is equals to a, that is at extreme position, a is equals to omega square into a. That is a is maximum. A is maximum. To understand, I am drawing simple pendulum diagram. Here this is the mean position and these are the extreme positions of simple pendulum. Here see, this is mean position, these are the extreme position. Velocity is minimum, acceleration is maximum. Here in this case, velocity is maximum, acceleration is minimum. Here velocity is minimum, acceleration is maximum. Okay, this is the information about velocity and acceleration. Okay, thank you.